This is math. Yeah, it doesn't look like normal math. You might even say it isn't real math, and you wouldn't be wrong. Welcome to the amazing world of IBI, or imaginary binary. There is so much fascinating math beyond what we usually encounter. We usually use something called the decimal system, or base 10. That means 10 digits, 0 through 9. You may have also heard of something called binary, or base 2. Binary uses only 2 digits, 0 and 1, but can express all the same number values as base 10. IBI is base 2i, I being the square root of -1. But how does that work? In all bases, you have something called a place system. In base 10, you have your ones place, your tens place, your hundreds place, and your thousands place. Similarly, in base 2, you have your ones place, your twos place, your fours place, and your eights place. An example of a base 10 number is 1,729. An example of a base 2 number is 1101, which in decimal is 13. Note that to get from one base to the next, in base 10, you multiply by 10. In base 2, you multiply by 2. The same pattern can be followed for IBI. You start with your ones place, then multiply by 2i to get to your 2i's place, then multiply by another 2i to get your -4's place, and then your -8i's place, and so on. Base 10 uses 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Base 2 uses 2 digits, 0 and 1. IBI uses 4 digits, 0, 1, I, and ein. Now you may be wondering, what is ein? Ein is a digit we created to represent the value 1 plus I. Using these 4 digits, you can express any real, imaginary, or complex number. This is something unique to IBI. When base 10 tries to express complex numbers, it needs to add a real number and an imaginary number. IBI does it in one fell swoop. Another cool thing about IBI is that no negative signs need to be used. We can form negative numbers with just those 4 digits. When we form numbers with those 4 digits, we call it standard notation, or SN for short. But sometimes we tack on the extra digits -1 and -I to make life easier. This is called negative notation, or NN for short. By using negative notation, we create many new ways to form numbers. Note that the equivalent in standard notation of -I is I1I, and the standard notation equivalent of -1 is I1. Here's an example of making an IBI number. Let's start with the number 3. If we look at our IBI place system, the first place with a coefficient less than 3 is the 2i's place. However, we need to turn our 2i into a 2. We do that by multiplying it by -I, since 2i times -I is 2. So -I is in our 2i's place. Now what's left over is 1, and we do that by simply putting a 1 in the ones place. So in IBI, we write 3 as -I1. If we convert it into standard notation, we simply exchange the negative I for I1I, so our final number is I1I1. Voila!
Thanks for watching the first part of our series on IBI. This video only scratches the surface of IBI, and there are so many more fascinating ideas we would like to share with you. Stay tuned for more to come.